Alright, time for our solutions for the sequences from tables and graphs assignment. So on each of these you're given a sequence, but it's not just the numbers and the lists like we've been doing so far. It either comes in the form of a table or a graph. And really, like, we've kind of done this before in writing functions from tables and graphs, but this time we're just kind of focusing on the sequence part of it because we're going to be writing a recursive function and an explicit function from the table or the graph. And then we got a question to answer on the end of each of these, okay? So, number one here, our first line here is time in minutes, and then our next line there is the candies that get devoured at that time. Okay, and I notice here that is an increase of 14, also increase of 14, increase 14, 14. So this one's an arithmetic sequence, so it's adding 14 each time. And my start value is at 20. It's not going to be here at 34, even though that's what it is when time is 1. Our start value, our initial value, is here at 20. Right, it's the first number in our sequence. So our recursive function looks the same as it has on our previous assignments. Our a sub n equals a sub n minus 1, as in a number is equal to the previous number, plus 14. And our first number in the sequence is 20. Oops, that 20 needs circle. Alright. The explicit one, again, follows the same sort of pattern that we had on our previous assignments. If you're not sure what that is, you can kind of look at the other videos or look at the notes that I gave you. Starts out here, and then 14 goes in front of n minus 1, and then we're adding 20 on the end. Okay, so now we got that down. Time to answer the question, how many candies will be devoured after 1 hour? Well, that's 60 minutes. So we need to figure out what the y value would be when the x value is 60. Well, we're not just going to plug in 60 in for n, because 60 minutes isn't the 60th term. Since the time actually starts at 0 and then goes, 1, 2, 3, everything's shifted to the right one. And so if we want what the number of candies at 60 minutes, we need to plug in 61, because we didn't start counting at 1, we started counting at 0. Okay, so we're going to plug in 61 into our function here. You got f of 61 equals 14 times 61 minus 1, and then plus 20. 61 minus 1 is 60. 14 times 60 plus 20 is going to give you 860. And that's going to be it for number 1. Continuing on here, number 2, you see our beautiful sequence going on here on our second row, 4, 12, 36, 108, 324. And I notice that the pattern here is multiply 3 every time. So our pattern, our common ratio is going to be 3. And so we got that, and our start value on our sequence here is 4. So we're going to write our recursive function like we have on our previous assignments. A sub n equals a sub n minus 1 times 3, because that's our common ratio. And then our first value, a sub 1, is 4. The explicit function is going to follow the geometric one, because we're multiplying each step. So we're going to have initial value times what we're multiplying by 3 by each time to the n minus 1 power. And that's our function there. The next question is, how many can be supported with $2,000? To figure that out, basically get the next few terms in our sequence here. So to get the next day, number of people, so 6 people. To get that, we gotta do 324 times 3. So let me do that real quick. 324 times 3 is going to give you 972. And that's not past 2,000 yet, so we're going to do the 7th day. To get that one, you have to take 972 and times it by 3, because we're times it by 3 every time. And so we're going to times it by 3 to get us 2,916. So if you only have $2,000, you're not going to get up to 7 because it requires more. And so it's going to be just 6 people. And that's going to be our first 2 problems, and we'll do another video for the next.